Good afternoon, children. Hope you all are fine. Welcome to my class. In our previous class, whatever we have discussed, hope you understood those properly. And today we will continue with the same chapter. And today we are going to discuss mixtures. So let us start. Today we are going to discuss mixture, its characteristic, types of mixture, then differences between compound and a mixture, and then we are going to discuss the separation of solid mixtures. There are different mixtures, and the separation of those mixtures we have to learn properly. So today we are going to discuss only solid mixtures. So what is mixture? The definition can be given as mixture can be defined as kind of matter which is formed by mixing two or more pure substances. It may be element and compound, or either element or compound maybe, or maybe both are there, in any proportion such that they do not undergo any chemical change and retain their individual properties. So therefore mixtures are impure substances. So just let us elaborate this. Suppose a mixture like salt and water. So if we mix salt in water, salt can get dissolved in water properly, and there will be no such chemical change. Only salt will get dissolved, the solid state of salt will disappear in water, and we will get the salty water. So in that mixture, in that salt water mixture, we are going to get all the properties of the salt. Means the water becomes salty. That means the individual property of salt will be there. So this is a mixture. There all the individual properties of the constituent elements will be there. They will retain their individual properties. So what will be the characteristic of mixture? A mixture consists of two or more pure substances. It may be two or more that exist together without any chemical combination between them. That means the example which I have given just now, if we take that example for salt and water, there will be no chemical combination between salt and water. We can get back the salt again by physical method, like by evaporation. If we evaporate the water, we will get back the salt. The mixture may be homogeneous or heterogeneous. After mixing any two or more substances, we can get a homogeneous or heterogeneous mixture. So what is homogeneous and what is heterogeneous mixture? We will be discussing that. So for salty water, we will get a homogeneous mixture, and for muddy water, this is another example of mixture, that will be a heterogeneous mixture. The components of mixtures vary in their proportions. What is this? We can, in a glass of water, we can mix one spoonful of salt, or we can add 2 spoonful of salt, or we can add more than that. So here you can see that the proportions may vary. We can mix any proportion. We can make the proportion according to our need in a mixture. So the proportion of the components may vary in the mixture. It's not fixed, which we have seen for compounds. There the proportions will be fixed everywhere. Next, mixtures do not have fixed melting and boiling points. They depend on the proportions of the components present in them. As the proportion of the components are not fixed, they can be changed. So the melting and boiling points, these are not fixed for mixture. If we mix more salt in water, then its boiling point will be more. It will at a higher temperature, it will start to boil. The components of mixture can be separated by simple physical methods. These methods we will see afterwards, but the components of the mixture can be separated by these simple physical methods like boiling or evaporation or freezing, like this. And for compound, we will see we cannot separate them by simple physical methods. There we have to take the chemical process to separate the components. So easily we cannot separate the components of a compound, whereas components of mixtures can be separated easily. Usually no energy change takes place during the formation of mixtures. Generally during the formation of mixture, no energy change takes place. Means the heat will be neither evolved nor absorbed. Mixtures cannot be represented by any chemical formula. Why? Because there are two or more than that element or compounds will be there mixed in a mixture. So there will be no such chemical formula. No fixed chemical formula is there for mixtures. We cannot represent them with, by any chemical formula. So what are the types of mixture? Mixtures can be of two types, homogeneous and heterogeneous. So homo, this term homo means same, alike. So what is that? The components are uniformly distributed throughout its volume and cannot be seen separately. For a homogeneous mixture, the components are uniformly distributed throughout the volume of the mixture and they cannot be seen separately. Example can be given as tap water. In tap water, with water, minerals are there along with some air bubbles also. Oxygen, carbon dioxide, this will be mixed with the tap water. But we cannot see the components separately in tap water. We will see only the water. So this is a homogeneous mixture. In the same manner, air, sugar solution or salt solution, these are also homogeneous mixture. Whereas heterogeneous mixtures, their components are not uniformly distributed throughout its volume. Somewhere the proportion will be more, somewhere the proportion will be less, and they can be easily seen separately. Examples are mud and water, muddy water. We can see the mud particles or the teeny clay particles in water. They are floating here and there in the water, so they can be seen separately. Sand and stone, there also we can see the particles separately, sand and stone particles. The proportion and the composition is not same everywhere. Oil and water again can be given as heterogeneous mixture. See here, we can understand this properly. In homogeneous mixture, see, in both the cases there are two different kind of particles. One is violet and another is green. But in homogeneous mixture, see, the distribution is totally uniform. The particles, both the colored particles are distributed uniformly. Everywhere the composition is same. If we take this part, this 4 or this 4, you will see the same composition everywhere. The distribution is uniform. But in case of heterogeneous mixture, here the concentration of this purple particles are more, and here at this part the composition of the green particle are more. That means the composition is not same everywhere. It's not, the particles are not distributed uniformly everywhere. Okay, so this is the main difference between heterogeneous and homogeneous mixture. Here are some examples of homogeneous and heterogeneous mixture: air, salt water, sugar water, brass. Brass means this is an alloy. Okay, so solutions, these are also we can say homogeneous mixture. And for heterogeneous mixture, soil, sand and water mixture, these are heterogeneous mixture, we can say. See, this is sand. Here different particles, we can see different sizes and their colors are different, composition is different. So this is heterogeneous mixture. For sand also we will see different color in different part of the sand, so their compositions are different and they are not mixed or distributed uniformly. This is again food, it's again a heterogeneous mixture. See, different types of mixture on basis of their physical state. So when we will mix solid, both the component will be solid. So homogeneous mixtures are solid homogeneous mixture that can be alloys of metal. Alloy means there will be two or more than two metals which will be uniformly mixed together, like brass, bronze, stainless steel. These are the example of this kind of mixture, where the solid mixtures will be mixed homogeneously. Whereas heterogeneous solid mixture, it's very easy: sugar and salt, rice and pearls, or sand and stone, sodium chloride and calcium carbonate, or common salt and chalk. Chalk is the calcium carbonate is the chemical name for chalk. Okay, and sodium chloride is common salt. So this can be mixed together to get a heterogeneous mixture, solid heterogeneous mixture. Next, come to solid liquid homogeneous mixture, when one component of the mixture will be solid and another will be liquid. Sugar and water, salt and water, this can be homogeneous mixture. Sulfur and carbon disulfide, we have seen earlier that carbon disulfide can dissolve sulfur, okay, to form a mixture, to form a solution. So this is again a homogeneous mixture, because here in the solution of sulfur and carbon disulfide mixture, we cannot separately see the particles of sulfur. Okay, it will form a homogeneous mixture. Iodine and alcohol, again iodine can get dissolved in alcohol, so this is again a homogeneous mixture. Whereas heterogeneous solid liquid mixture will be sand and water, because sand cannot get dissolved in water. Mud and water, this is again sugar and oil, they cannot mix together, so these can be given as solid liquid heterogeneous mixture. Next, come to liquid homogeneous mixture, where both the components are liquid. Water and alcohol, they will get mixed together properly, homogeneously. So water, alcohol, acetone and water again can form a homogeneous mixture, where both the components are liquid. Whereas heterogeneous liquid mixture will be oil and water. If we mix oil and water together, then as oil is lighter than water, so it will float on the upper level of that mixture, and water will be at down. So they will form two separate layers. That means they are not making any uniform mixture. The proportion or the composition is not same everywhere. So oil and water will be a heterogeneous mixture. Next, liquid and gas. Tap water. Why tap water? Because in tap water, carbon dioxide, oxygen, these are mixed together, so they will form a homogeneous mixture with tap water. So in tap water, water with carbon dioxide and oxygen is there. The same manner, ammonia and water. Ammonia is very much dissolved in water. It's very much soluble in water, and it will form a homogeneous mixture. Ammonia is a gas, and when it will get dissolved in water, it will form a solution, ammonium hydroxide. Carbon dioxide and water, again this will form a homogeneous mixture. Whereas soap lather is the heterogeneous liquid gas mixture. Here with the liquid soap or soap and water, if we mix together, we will get the bubbles of soap, which is called soap lather. So there air will be trapped inside the soap particles, and bubbles will be formed. So they will form a heterogeneous mixture. They will float as the particles or the foam is lighter than water, so it will float on the upper layer of the soap water. So this will form a heterogeneous mixture. Next, gas homogeneous mixture. Here, as all gases are miscible, so they will form only homogeneous mixture. There will be no heterogeneous mixture for gas and gas. So any two gases can be given as an example for this. So air is a homogeneous gas mixture, we can say. Next, come to the differences between compound and mixture. This you know already. So compound, it's a pure substance, because in compound you will get only one kind of particle, whereas mixture is an impure substance, because there we will get different kind of particle. Compounds are always homogeneous, whereas mixtures may be homogeneous or heterogeneous. We know this. A compound has a fixed composition because it is formed when two or more pure substances chemically combine in a definite ratio by mass. So for compound, a fixed composition can be given. A formula, a fixed chemical formula is there for a compound. But for mixture, there are no fixed composition, because it is formed by mixing two or more substances in any ratio without any chemical reaction. So there are no such definite chemical formula or fixed composition for mixture. Next, formation of a compound involves a change in energy. During formation of a compound, energy changes must, it will either evolve or absorbed. But for mixture, formation of a mixture, during the formation of a mixture, it doesn't involve any change in energy generally. Next, compounds have a specific set of properties. We know this. Compound have a specific set of properties. All the compounds have a specific set of properties, whereas mixtures do not have any specific set of properties. They will show all the properties of the constituent elements or compounds. Components of compounds can be separated only by complex chemical process, whereas for mixtures they can be separated by simple physical methods of separation. So these are the differences between compound and mixture. Let's move on to separation of mixture. So before doing that, why we need to separate the mixture, that we have to know first. So two reasons are there, two purpose of separations are there. One is to remove unwanted and harmful substances. Sometimes in mixture some unwanted substances or harmful substances are there, which we need to remove. We need to separate from the substance which are useful to us. Okay, so we need to separate them, the harmful substances from the useful substances. So we need to separate the mixture, or to obtain pure and useful substances. Actually both are interrelated. both are same. So to obtain pure and useful substances and to remove unwanted and harmful substances, we need to separate a mixture. Like suppose in rice or in pulse, if some stones or unwanted particles are there, so those are unwanted, those are harmful, so we cannot intake those. So we to get back the pure and useful grain, food grain or pulse, we need to separate the stones. So those are called unwanted and harmful substances, we can say, and we need to separate them. So this is the reason for or purpose for separation. So what is the principle for separation? It will depend on three things. First is type of mixture and their physical state. So what type of mixtures are they, and what is their physical state? That is a very big factor. The separation techniques or the principle of separation will depend on this part. And next, size, shape and color of the mixture. This is another point on which the separation principle of separation depends, because during the hand picking, just the example which we have discussed right now, just now we have discussed, for to separate the stones from pulse or food grain, like the pulse and the stone, these are having different shapes, size and color, so they can be easily seen separately, easily recognized, and can be separated easily. Next, characteristic properties of the components of the mixture. So on basis of this, the characteristic property, the principle of separation depends, because there are when we are going to discuss the techniques, we will get to know this properly, because on this basis the maximum separation techniques are they depend on this part. Okay, so let us do this. First of all, today we will discuss only solid-solid mixtures, separation of solid-solid mixtures. So what are they? First one is mechanical removal or hand picking. There are many are there: hand picking, winnowing, pressing, sieving. These are mechanical removal of solid mixture. Hand picking, just it's very easy, like separation of stone from food grain, or stone from rice or pulse, or separation of pulse and rice. These are called, but just using our hand, by hand we can remove the unwanted substances or remove the different components of the mixture. This is called hand picking, or just separating the stone from the pulse and all. Next, winnowing. In this manner we can separate the husk from the food grain, because husk is light in weight, so easily they can be blown away in this process, in this winnowing process. And as the food grain is heavy in weight, so they will just directly fall down on the ground, just because of the gravitational force. So this is winnowing. This is the winnowing process, we can say. And tracing, in this manner we can separate the like the wheat plant or the paddy plant and all. So from the whole plant, when we need to separate the grain from the chaff, we need to separate the grain, we will use this threshing process. There we will just beat the whole plant on the threshing plate and all, and the particles on the rice on the food grain will get separated, and the unwanted plant will be thrown away. Sieving, this process we frequently use at our home to separate the husk from the flour or rice flour like this. The particles and the size of the particles are different, so the fine particles on the powdery particle of this flour or rice flour will come out, or will come out from the hole of this uh, sieving apparatus, sieve, and the bigger particles will be left behind on the upper portion of the sieve. So in this manner we can separate the unwanted substances. Next, magnetic separation. This process we will be using where one particle, one component of the mixture will get attracted by magnetic particle will be there, like iron, nickel, cobalt. If these particles will be mixed with another non-magnetic particle, then magnetic separation is the best process to separate those things. Here we have taken sulfur and iron fillings together in this mixture. Iron and sulfur both are there. So if we use the magnet, iron particles will get attracted by the magnet. It will get stick to the magnet, and sulfur particle will left behind in the container. So iron fillings and sulfur can be separated in this process. Next, gravitational method. Here if we take the sawdust and sand together, sawdust and sand particles together, this mixture of sawdust and sand, then if we add water in it, as sand particles are heavy in weight, so they will settle down at the bottom of the container or the beaker, and as sawdust is light in weight, so they will float on the upper level of the water. So this sawdust can be separated by using a filter paper, and sand will remain here on in the beaker. Okay, so this process is called gravitational method, where the heavy particles, because of the gravitational force, they will settle down at the bottom of the container, and the lighter particles will be floating on the upper portion. Next, sublimation process. This process can be used to separate the substances, where one substance can show sublimation, like to separate ammonium chloride and sodium chloride. Both are look alike. Ammonium chloride is white crystalline substance, just like table salt or common salt. So if they get mixed together, we cannot separate them by any other means. They will be both can get dissolved in water, so those other processes are also cannot be used to separate these two. So here we can use the property of ammonium chloride, which is sublimation. Ammonium chloride can show sublimation, but common salt or sodium chloride cannot. So this property we can use here to separate these two. Here we will, in a china dish, we have taken the mixture, and we are going to heat this, but before that we will be taking a conical flask. We will be taking this inverted tube. Okay, this is not conical flask, this is a tube, or this we can use this use during the we can say filtration process. Okay, so this is a funnel. So this is a funnel, so we will keep it in inverted manner, in this manner, and we will use some cotton plug so that the ammonium chloride vapor cannot come out from the from this funnel. Now what we will do, we will light the burner, and we are going to heat this china dish. So ammonium chloride will get heated, and it will sublime. So here you can see the vapor, or the vapor of ammonium chloride, the white vapor of ammonium chloride, and this will solidify afterwards in this inner wall of the inverted tube or the funnel, and common salt or sodium chloride will remain in the china dish because it will not show sublimation. So after that, we can, from this inner wall of the funnel, we can collect the ammonium chloride and we can separate this. In this process, we can separate any substance, any sublimable particle, like camphor. We can separate sand and camphor, or sand and iodine we can separate, iodine and sodium chloride we can separate. So this process can be used to separate those mixtures. Next, solvent extraction method. What is this? In this method we can use for those mixtures where one substance, one component is get mixed, will get dissolved in the solvent used, and another one will remain undissolved, unsoluble in the same solvent. So if we take salt and sands mixture, then we can use water as the dissolving solvent. Here salt will get dissolved in water, but sand will remain undissolved. So here in the beaker you can see the mixture of salt, water and sand. Salt will get dissolved in water to form a uniform mixture to make a homogeneous solution, but sand will remain undissolved in it. So after that, if we use the filtration process, here this is the conical flask and this is the funnel, and here we will use the filter paper. So if we pour the salt and sand mixture along with water, the sand will remain undissolved. It will just become as residue. It will remain as residue in the filter paper, and in the filtrate, the salt solution we will get as the filtrate. Now with the salt solution, if we evaporate the solution, then water will get evaporate. Water gets evaporate, and this sand will remain in the filter paper. And for salt solution, the water will evaporate and salt will remain in the evaporating dish. So in this manner we can separate salt and sand. So this process is called solvent extraction method. Now, fractional crystallization. In this process, we can separate common salt and potassium nitrate. These two can be separated by fractional crystallization. So what is this? During this solvent extraction process, what will be that both the substances, like here we have taken the salt and common salt and potassium nitrate, both we have taken, both can be dissolved in water, but the dissolution or the in the rate of dissolution, we can say, that is different. The rate of formation of solution is different. Potassium nitrate is very much it will readily dissolve in water. It will make very easily, it will make the solution, whereas common salt will not get dissolved in that manner. Okay, so how we will do the process? We will mix both. With the mixture, we will be dissolving in the solvent, and then we will heat that. Now the potassium nitrate will get dissolved, both the substances will get dissolved, and then after that we will cool it down. So as potassium nitrate will get dissolved faster, it will get separated when we will cool down the substance, when we will cool down the mixture. potassium nitrate will get separated first. Okay, it will crystallize first from the solution, and this process we will repeat again and again. After separation of the potassium nitrate in the first part, in the first step, again we will heat the solution and again we will cool it down. So again more potassium nitrate will get separated from the solution. So this process can be repeated again and again to get back the whole potassium nitrate, or the all the potassium nitrate which will be dissolved, that can be separated in the manner in this manner, and the other component will remain in the solution. So that can be evaporated, the solution can be evaporated to get back common salt. Okay, so this process is called fractional crystallization. So this is all for today. Now we are going to discuss the worksheet which was given in our last class, in our previous class. But here you pause the video, you go through the study material, and you just see if anywhere you are having any doubt. You just go through that and then come back to this video again and get the worksheet, the solution of the worksheet, previous worksheet which was given in the last class. Okay. So this was given, this worksheet was given in our last class. So first question is define element and compound. This I hope no need to say again. You will get in the, you can write your own, or this you will get in the study material as well. Next, give two examples for each of the following: metal, non-metal, metalloid, inert gases. This also you will get in there only in the study material, or you can do your own, I hope. Differentiate between pure and impure substances. So what is that? Pure substances, they contain only one kind of particle, whereas impure substances, in impure substances we will get two or more particles, different kind of particles we will get. Pure substances are examples of pure substances are elements and mixtures, whereas impure substances are for pure substances, examples will be element and compound, whereas impure substances are mixtures are the example for impure substances. Pure substances, for this we can give proper chemical formula or chemical composition can be given for pure substances, whereas for impure substances we cannot give any such proper composition, because the proportions of the substances can be changed, and there are no such chemical bond between the components. So these are the difference between pure and impure substances. Next, homogeneous and heterogeneous substances. This you can write your own, I hope. In homogeneous substances, the components are mixed uniformly. Components are distributed uniformly throughout the mixture, throughout the volume, and the particles cannot be seen separately. Whereas for heterogeneous substances, the particles can be seen separately, and the composition is not same throughout the volume. The composition is different in different part of the volume. Okay, so examples you can give for homogeneous as well as heterogeneous substances. Next, write the chemical name of the following and also give their molecular formula. So baking soda, this is sodium bicarbonate. This is the chemical name of baking soda, sodium bicarbonate. Here, if you don't have pen and paper with you, then just pause the video and bring those, because here you have to write down the answers. Baking soda is sodium bicarbonate, and its chemical formula or molecular formula will be NaHCO3. Next, vinegar is acetic acid. This is the chemical name. So you are going to make two columns, one for chemical name, another for molecular formula. In chemical name column, you will be writing acetic acid for vinegar, and molecular formula will be CH3COOH. This we have discussed in the study material. Also, you will be getting this. Next, marble, chemical name is calcium carbonate and formula is CaCO3. Sand is silicon dioxide, SiO2 is the molecular formula. Okay, next, name a soft metal. A soft metal is sodium or potassium, also you can write. Metal which is brittle, that will be zinc. A non-metal which is lustrous. Lustrous non-metal is iodine and graphite, both can be given. A liquid metal is mercury. A metal which is a poor conductor of electricity, that is tungsten. Tungsten is a metal, but it's a poor conductor of electricity. A non-metal which is a good conductor of electricity, this is graphite. Non-metal but good conductor of electricity. A liquid non-metal is bromine. Bromine is reddish color liquid, but it's a non-metal. Next, hardest naturally occurring substance, this is diamond. And inert gas, any of the 6 inert gases name you can write. So helium, neon, argon, krypton, xenon or radon, any one. Next, how is sodium chloride different from its constituent elements? This you try to write your own, and I'm just giving the points which you have to write. Sodium chloride, the components are sodium and chlorine. Sodium having the property of being very much reactive and is a soft metal. So these two properties are there for sodium. It's very much reactive, that's why it's generally kept under kerosene so that it cannot get exposed to air or water. Whereas chlorine is, it's a non-metal, it is a poisonous greenish yellow gas, and when we will, after the reaction of sodium and chlorine, when we are going to get the sodium chloride common salt, it's a solid, it's a crystalline white solid, and it is useful, it's non-poisonous. So here we can say, we can see that sodium and chlorine, after both are poisonous, and after getting combined chemically to form the compound sodium chloride, both of the components, they have lost their property, and they have formed a totally different compound which is having a totally different property than that of the constituent elements, because sodium chloride is common salt, is non-poisonous, whereas sodium and chlorine both was poisonous. So this is the difference, you can see, you can write it in your own word. Okay, next, why is iron sulfide a compound? Why we will call iron sulfide a compound? This compound contain iron and sulfide, these two elements. So here again we will be saying that the components have lost their property after forming the compound. In the compound, iron and sulfide, they have combined chemically, and after combination of these two, we have got a totally new compound, iron sulfide, which is having different property than that of the iron and sulfide both. Iron sulfide, it's neither, attracted by the magnet and not get dissolved in carbon disulfide, which is the properties of iron and sulfur respectively. So it will be a compound. Okay, so this was the answer for this worksheet. So for today, this is all for today, children. You just go through the study material properly and do the worksheets regularly. Keep the things ready with you and just do your study properly. Take care of yourself and have a nice day. Okay, thank you. That's all for today.